The following is a course module from Basic Algebra Concepts, available at argotsmedia.com. Many important formulas use x squared or another variable squared. The formula for the area of a circle is an example. Many important formulas use x squared or another variable squared. The formula for the area of a is an example.
Good work. The formula for the area of a circle is an example.
We need to know some special names for the parts of a circle because the measures of these parts are used to calculate the area. Our first part is the center of the circle. The radius is a fixed distance from the center of the circle to points on the circle. Some quick review. The center, the radius, the circle. The radius is the fixed from the center of the circle to points on the circle.
Very good. The radius is the fixed distance from the center of the circle to points on the circle.
The area of the circle is the amount of flat surface inside the circle. A will stand for the area. Again, some quick review. The center, the radius, the circle, and the area. The area of the circle is the amount of flat surface, the circle.
Good work. The area of the circle is the amount of flat surface inside the circle.
Mathematicians have discovered a very important special number called pi that is used to calculate the area of a circle. Pi is approximately equal to 3.14. Pi is one of those special numbers called irrational numbers. No one knows what pi is exactly, but we can use very good approximations. The special number pi is approximately equal to which of the following?
Nice. Pi is approximately equal to, answer choice C, 3.14.
Let's see what our area formula is for a circle. The area of a circle is equal to pi times r squared, or r to the second power. Put another way, the area is equal to 3.14 times the measure of the radius squared, or raised to the second power. Which of the following is the area formula for the circle?
Nicely done. The area formula for the circle is area equals pi times radius squared.
Let's look at a specific example. We have a circle with a radius of 5 inches. We want to calculate the area of this circle. We remember our formula, that the area is equal to pi times r squared. Beginning our calculation, the area will be equal to, we replace pi with the value 3.14 times whatever r is squared, and our radius is 5 inches. If pi is approximately equal to 3.14 and the radius is equal to 5 inches, and our formula says that the area is equal to pi times r squared, which of the following is true?
Nicely done. The correct replacements are answer choice C.
Continuing with our calculation, our area will be equal to 3.14 times 5 inches squared is like 5x squared. 5x squared is 25x squared. 5 inches squared is 25 inches squared. If A equals 3.14 times the quantity 5 inches squared, then which of the following is true?
Very nice. Answer choice C is the correct calculation.
Going further with our calculation, the area is equal to 3.14 times 25, and we have calculated our area, and it works out to be 78.5 square inches. If the area equals 3.14 times the quantity 25 inches squared, then which of the following is true?
Correct. Our final answer is answer choice B.
Let's look at another problem. We have another circle, but this time we know its area is 50.24 square inches. And our problem is to find what the radius is of this circle. Again, we know the area is 50.24 square inches, and we're looking to find the radius of a circle that would have that area. Beginning our calculation, we replace A with the value in the problem, 50.24 square inches, is equal to, and we replace pi again with the value 3.14 times our radius squared. If the area is equal to pi times r squared, and pi is approximately 3.14, and we know that the area is 50.24 inches squared, then which of the following is true?
You were right. Answer choice A shows our correct replacements.
Going further, we want to get r all alone, so we divide the right-hand side of the equation by 3.14. We must do the same thing to the left-hand side of the equation and divide it by the value 3.14. If this equation is true, then which of the following is true?
Very nice. The next step in our calculation is answer choice B.
We are at this point now. 50.24 divided by 3.14 works out to be 16 inches squared equals 3.14 divided by 3.14 is 1 times r squared is r squared. If this equation is true, then which of the following is true? 50.24 over 3.14 is equal to 16.
Very nice. The results of our divisions are answer choice A.
We can use our symmetric rule to make this equation look better with the variable stated first. We can write r squared on the left-hand side, and we can move 16 inches squared to the right-hand side. Going further with our calculation, we want to talk about r, not r squared. So we will take the square root of the left-hand side of the equation, and we must take the square root of the right-hand side of the equation as well. If r squared equals 16 square inches, then which of the following is true?
Very good. The next step in our calculation would be answer choice C.
We are at this point now. The square root of r squared will be equal to r. Because r can only represent a positive number in our problem, we are finding a measure of distance. We do not have to say that the square root of r squared is equal to the absolute value of r, is equal to the square root of 16 inches squared. The square root of 16 is 4. The square root of inches squared is inches. So we can replace the square root of 16 inches squared with 4 inches. And we have found the radius of our circle. It is 4 inches. If the square root of r squared equals the square root of 16 square inches, then which of the following is true?
Very nice. Our calculations show that the radius is equal to 4 inches.
Again, many important formulas use squared variables in them. The formula relating the sides of a right triangle is another important example. A right triangle has a right angle. Our formula talks about the measures of the sides of right triangles. We need to label those measures with variables in order to use our formula. So we're going to label this first short side with the variable a. And we label the other side with the variable b. The side opposite the right angle we are going to label with the variable c. Our formula talks about the sides of right triangles. We need to label those measures with variables in order to use our formula.
Very good. Our formula talks about the measures of the sides of right triangles. We need to label those measures with variables to use our formula.
This formula that we're about to discuss is very useful in a number of areas of mathematics and engineering. The formula is c squared equals a squared plus b squared. Notice that this formula is saying that the square of the measure of side C equals the square of side A plus the square of side B. It is not saying that C equals A plus B. It's also important to remember that C is always the measure of the side opposite the right angle. And it is always a positive number because C represents a measure of distance in these problems. For that reason, whenever we talk about the square root of C squared in these problems, we can say that the square root of C squared is C, rather than having to say that the square root of C squared is the absolute value of C. If we have this triangle, then which of the following is true?
Very nicely done. Answer choice C is the correct formula.
We can use our formula to find the length of one side if we know the length of the other two sides. Let's look at an example. If our one side measures 3 inches and another side measures 4 inches, we can use our formula to find the measure of side C. We need to remember our formula. C squared equals A squared plus B squared. We begin our calculation by replacing A with its value in this problem, 3 inches. And we replace B with its value, which in this problem is 4 inches. If we have this triangle and C squared equals A squared plus B squared, then which of the following statements is true?
Good work. Answer choice A shows the correct replacements for our formula.
We now have C squared equals 3 inches squared plus 4 inches squared. Going on with our calculation, C squared equals 3 inches squared is like 3x squared. 3x squared is 9x squared. So 3 inches squared will be 9 inches squared, or 9 square inches. Plus 4 inches squared is like 4x squared. 4x squared is 16x squared. So 4 inches squared calculates to be 16 inches squared, or 16 square inches. If we have C squared equals 3 inches squared plus 4 inches squared, then which of the following statements is true?
Very good. Answer choice B shows the correct calculations.
We are at this point now. We have c squared equals 9 square inches plus 16 square inches. Just as we say 9x squared plus 16x squared is 25x squared, we can say that c squared equals 25 inches squared. If we have c squared equals 9 inches squared plus 16 inches squared, then which of the following statements is true?
Very good. Answer choice B is the next step in our calculation.
Because we want to talk about c all alone, we take the square root of the left-hand side of the equation. And our rules tell us that we must take the square root of the right-hand side as well. The square root of c squared works out to be c, because in this problem, c can only represent a positive number, a measure of distance. We do not have to say that the square root of c squared is equal to the absolute value of c. The square root of 25 is 5. The square root of inches squared is inches. So our answer is c equals 5 inches. If c squared equals 25 square inches, then which of the following statements is true?
Good work. We need to take the square root of both sides of the equation.
If the square root of c squared equals the square root of 25 square inches, then which of the following statements is true?
Very nice. Answer choice A, c is equal to 5 inches, is our final solution.
And we have now found the measure of the length of our side. The side C has a fancy name. It is formally called the hypotenuse. And our formula that helped us find the measure of this side is formally called the Pythagorean theorem. What we have found is that if A is equal to 3 inches and side B is equal to 4 inches, then side C, the hypotenuse, must measure 5 inches. Left-click and drag the matching phrase on the right to the correct word on the left.
Good work. The hypotenuse is the side opposite the right angle, and the Pythagorean theorem is the name of our formula.
Another interesting formula that uses squared terms is the kinetic energy formula for a moving object. The energy of a moving object depends on the velocity or speed that it is moving at and the mass or weight of the object. Our formula for the kinetic energy of a moving object is 1/2 the mass times the velocity squared. And we normally write this as the kinetic energy equals 1/2 mv squared. The velocity and the mass determine the kinetic energy of a moving object. If v equals the velocity or speed and m equals the mass or weight of a moving object, and the kinetic energy equals 1/2 times the mass times the velocity squared, then which of the following formulas is true?
Very nice. Answer choice C is correct. Kinetic energy is equal to 1/2 mv squared.
Let's look at a specific example. Let's say that our car has a mass or weight of 1,000 kilograms, and it's moving at a velocity of 2 meters per second. The kinetic energy of our car when it's in motion is 1/2 mv squared. Let's begin to calculate that kinetic energy. The kinetic energy will be equal to 1/2 of 1,000 kilograms, the weight or mass, times the speed squared. The speed is 2 meters per second. If the mass equals 1,000 kilograms and the velocity equals 2 meters per second, then which of the following shows the correct replacements in our formula?
Very nice. Answer choice A shows the correct replacements.
Going on with our calculation. The kinetic energy will be equal to 1/2 of 1,000 is 500 kilograms times 2 meters per second squared will be 4 meters squared over seconds squared. If our formula appears as this after replacements, then which of the following is true?
Good work. Answer choice B shows the correct calculations.
Going on with the calculation. The kinetic energy will be equal to 4 times 500 is 2,000 kilogram meters squared per second squared. These are some fancy units, but a kilogram meter squared per second squared is 1 joule. So we can say that the kinetic energy of the vehicle is 2,000 joules. Let's try to visualize this energy. Our vehicle weighs about 1 ton, and it's moving at 2 meters per second, about 4 or 5 miles per hour. When the vehicle is stopped, there's a collision. The energy that's released in that collision is one way to visualize the amount of energy that the car had when it was in motion. When our car collides with the wall, the release of energy is approximately 2,000 joules, because that was the energy that it had when it was in motion. And when it is stopped, that energy had to go somewhere. In other words, how bad the crash is the kinetic energy of the car. If the kinetic energy equals 500 kilograms times 4 meters squared per second squared, then which of the following is true?
Very nice. Answer choice C shows the final calculation.
Let's look at another example. Again, our car weighs 1,000 kilograms, about a ton. But this time, the car is moving at 8 meters per second, 4 times as fast. Let's calculate its kinetic energy using our formula. Again, we begin our calculation. The kinetic energy equals 1/2 of 1,000 kilograms again, but this time times 8 meters per second squared. If the mass equals 1,000 kilograms and the velocity equals 8 meters per second, which of the following replacements in our formula are correct?
Nicely done. Answer choice A shows the correct replacements in our formula.
Going on with our calculation. The kinetic energy equals 1/2 of 1,000 is 500 kilograms. But 8 meters per second squared is going to be 64 meters squared per second squared. Going further, the kinetic energy will be 500 times 64 will be 32,000 kilogram meters squared per second squared. In other words, the kinetic energy will be 32,000 joules. If the kinetic energy equals 1/2 of 1,000 kilograms times 8 meters per second squared, then which of the following is true?
Very nice. Answer choice C shows the correct calculations.
If the kinetic energy equals 500 kilograms times 64 meters squared per second squared, then which of the following is true?
Good work. Our final step with the correct units is answer choice B.
Let's try to visualize this second example. Again, the car weighs about 1 ton, but it is moving this time at 8 meters per second, about 18 miles per hour. This time, our collision is much larger. The kinetic energy released in the collision is 32,000 joules. Let's compare these two examples. The first car had a collision that released 2,000 joules of energy. Its kinetic energy while it was in motion was approximately 2,000 joules. The second car, when it collided with the brick wall, released 32,000 joules of energy. That meant that its energy when it was in motion was approximately 32,000 joules. The second car moved only 4 times faster than the first car. But we can see that the crash of the second car was 16 times worse than the crash of the first car. The second car moved only 4 times faster than the first car, but the crash was times worse than the first crash.
Very nice. The second car moved only 4 times faster than the first car, but the crash was 16 times worse than the first crash.
The kinetic energy formula is an example of a very important idea in science and math called exponential growth. If we look at this table, we see as the value of v increases, the velocity, by 1, the value of v squared increases by much more than 1. If you remember in our first car example, the first car traveled at a velocity of 2 meters per second. That meant that the factor in the kinetic energy calculation for v squared would be 4. In the second example, our car traveled at 8 meters per second. But that meant that its factor in the kinetic energy calculation would be 64 meters squared per second squared. Notice how much larger v squared is in the second collision versus the first collision. 64 is 16 times larger than 4. The second collision was 16 times more severe than the first collision. This is an example of exponential growth, and it's a very important effect in science and math. The kinetic energy formula is an example of a very important idea in science and math called exponential.
Good work. The kinetic energy formula is an example of a very important idea in science and math called exponential growth.
Just as we do with equations, we can use the solve function with some of the newer math graphing calculators to solve formulas. In this case, c squared equals a squared plus b squared. Since we have more than one variable in our formula, we need to tell the calculator which variable it is solving for. So in most calculators, you need to specify the variable with a comma in order to tell the solve function which of the variables it's solving for. We also need to tell the calculator what values the other variables have. Here we have a is equal to 3 and we have b is equal to 4. It's running off the screen a little bit. When we press the execution key, we get the result of our calculation. We get two values, c equals a -5 and c equals 5. These are solutions to this formula. But remember, the solution to our problem was that we were looking for a measure of distance, and we were only allowing c to represent positive numbers. So for the solution to our problem, we chose to use only the solution c is equal to 5 because we were restricting our solutions to positive numbers. Your solution to your problem may be more than just the solution to the equation. If we type carefully, our calculator can also handle units. Let's look at our kinetic energy example. Notice we have our formula typed in with parentheses around the fractions, and we have kinetic energy equals 1/2 times the mass times the velocity squared, and we want to calculate the kinetic energy. We also want to assign the values 1,000 kilograms to the mass and 8 meters per second to the velocity. Going on with our calculation, when we press the execution key and we get the result, kinetic energy equals 32,000 kilogram meters squared per second squared, or 32,000 joules. We can use which of the following functions on the calculator to solve formulas?
Good work. We can use the solve function on the calculator to solve formulas.
The following titles are available at argotmedia.com. Basic Algebra Concepts is an individualized, programmed learning approach to e-learning based on the work of B.F. Skinner, Norman Crowder, and others with early learning machines. Sample videos on the course content and shop pages demonstrate our approach. Some of our strategies focusing on the young learner are: third grade reading level. Writing is encouraged but not required. We've designed the simplest learning steps possible. There is a strong emphasis on pattern recognition. Each slide contains clear animation and narration. There are frequent low-level assessments designed to reinforce and motivate. The student is provided with immediate feedback on their responses, as well as positive reinforcement for correct responses. There is an extremely high level of interaction between the student and the program. The learning is self-paced. There is no homework, worksheets, or tests. There are assessments at every step of the learning process, designed for success and motivation.